Okay, this is number 7, and we'll continue in the financial economics series, and we'll continue from before, but I believe when we left off last time we said the future was broken into 2 periods. One we'll call the forecast period, and the latter, which goes from sometime in the future. A lot of people choose 5 years, but it really ought to be an economic choice, which I'll explain in a minute, to the residual value period. And here we assume that the company has net present value greater than 0 investments available to it, and here we assume it does not. Doesn't mean the company's going to die, it just means it will be a cost of capital player, if you will. This just another way to write this, you can invest at greater than the cost of capital. Here investments will give a return equal to the cost of capital. Now, how realistic those assumptions are, it depends on the individual case. Many people just arbitrarily choose a forecast period of 5 years, crank out a perpetuity or a growth in perpetuity for residual value and use that as their value. That's a little naive, but you might start with something like that. Okay, I want to switch over now and take you through some algebra, and I'll use some symbols. S is going to be sales. P is going to be earnings before interest and taxes, EBIT to sales. T will be a tax rate. So what I come up with is profit after tax then is really just S times P times 1 minus T. In fact, if you ever read any of the things I write, or you'll see this kind of formula all the time. I'd like to add another little, some more here. Delta S will be the change in sales, which is the sales in the first period less the sales in the 0th period. So if I had S2, it would be S2 minus S1 and so forth. Now, I want to define another thing called little f, which is the incremental capital expenditures you need to get a new dollar of sales. How's that for a tongue or a mouthful? It's going to be CapEx, capital expenditures, over and above depreciation, divided by the change in sales. And another one called W, which is the incremental working capital, or the change in working capital, divided by the change in sales. Okay. Now, a point I want to make carefully, if you're ever doing this, just make sure that this depreciation that's here is exactly the same as the depreciation that's hiding inside earnings before interest and taxes. Because when you calculate that number, depreciation is an expense, but it's not a cash expense, it's a non-cash expense. Make sure they're the same. And then I think you'll see that in the equations, when you calculate cash flow, you'll get the right answer. Now, we're going to introduce G, which is sales growth. I could change it back to yellow, but I think you can let me survive with that. So the cash flow, let's take cash flow in the first period, is going to be the sales in the 0th period times 1 plus G. That moves it. This is sales in the first period times EBIT to sales in the first period times 1 minus the tax rate. Let's assume it's constant for now. And now we got to subtract off the cash we spend for investments, which is simply F plus W. Now, if they're going to be different in each period, we'll mark these, times delta S. And actually, let me go back. Let's go to green. That's a nice one. This is equal to G times S0. So in general, delta SI is always equal to G times SI minus 1. Now, and by the way, if this kind of algebra bothers you, or you're saying, gee, that's kind of tricky to follow, then you got to do a lot more work on your algebra, because this is really simple stuff, and you ought to be able to just do this sort of thing cold. Okay, so here I've got a formula for the cash flow, which really talks about what's coming in from the income statement, if you will. But remember, depreciation's in here, but in here, you remember the depreciation is subtracted, and since it's subtracted from here and here, it cancels itself out. So this cash flow is true cash that comes in for that period. This is the kind of formula of cash flow of period 1, period 2, period 3, period 4, period 5, and so forth that we use to discount. All right, now let's just move on a little bit here. And I want to talk about a subject called threshold margins. Threshold margins. Now, this is a concept that can be quite useful, but again, it's a fairly crude model, and you have to be careful where you apply it. But I want you to just understand how this works. So, if I do my traditional drawing here, this is time, and this is dollars. All right, now, what I'm going to do is say, let's suppose at year 1, beginning of year 1, we invest some money. And I'm going to say that that's going to be, well, I'm sorry, okay, we do an investment, and then we're going to get a bunch of little arrows up here. Forever. Out to infinity. And I'm going to call this investment is going to be this capital and working capital investment. So this is going to be F plus W times the change in sales. And these guys are going to be the margin you get, and I'm going to put a little prime on it, times 1 minus tax times delta sales. Okay, now we know that the present value of this is a stream, so the PV is going to be that P prime times 1 minus T times delta S over K. Remember, that's how you do a perpetuity. You take whatever one of these is, you count all this, and then you just divide by K. And the present value of this, since we're starting at the beginning of the period, is just this, is just what it's written. You're not discounting at all. So if you look at this, the idea is, when's this stream equal to this stream? Okay, well, all we got to do is set these two equal. So we just set this equal to this. So if these are equal, what do we have? Well, we have P 1 minus T times delta S over K equals F plus W times delta S. And of course, these cancel out. I'm assuming they're not, even if they were 0, it cancels out. It doesn't make any sense, of course, if they're 0. So now we can solve for this, for the P, and let me call that P star, because that's just a special value when these are equal, will equal, and again, you ought to be able to do this very quickly, it's K times F plus W. I just move the K over here and the 1 minus T down here, 1 minus T. Now let's plug in a few numbers. Let's say the cost of capital is 8%. Let's say F and W is 50%. It's not a bad number, by the way, for a general manufacturing. The amount of working capital and fixed capital needed for $1 of sales is about 50 cents. 1 minus tax rate, let's say taxes are at 40 cents on the dollar, so it's 0.6. And if you work this out, do a little arithmetic here, you get 6.6%. Okay, we're running out of time, but basically what this tells you is that if the margins on new business isn't more than 6.6%, you'll be destroying value. Let you think about that, and we'll pick it up on the next one.